We're J Educational Products, and we were tasked with creating a BRG for students to get a hands-on experience on topics that they've been learning inside the classroom.
So these are some of the parts from our mission statement. The product is a BRG course, and it'll transport a ping pong ball across 3 stations on a pegboard, and these will teach the students different physics concepts, and it'll give them a hands-on approach to learning these concepts instead of just doing the problems in class. And we want to create a product that is cheap to produce, but it'll also be cheap for consumers to buy. And it's assumed that the students have already been taught these different physics concepts and that they'll be able to apply these concepts into the BRG course. And we're aiming to get customers from the school board, from teachers, and even like homeschoolers that are learning these concepts at home, not in a school environment. So this is our Gantt chart. It shows kind of the progress that we're on right now in terms of our project. And as of right now, we've only been gathering customer needs and doing some preliminary planning for our project and gathering different ideas from different types of products that are similar to ours. But we have 2 couples in our chart where we'll be doing 2 tasks at the same time, but most of our other tasks are in chronological order. And most of them only last about 1 week or 2 weeks, depending on the complexity of each task. So the first customer that we chose to interview was my physics teacher from high school. He teaches a lot, he teaches all physics courses, including honors physics and AP physics. He has a strong background in physics as well, and he's the leader of a club called Physics Olympics. So we thought he would be a good customer to choose because he would be one of the main people that would buy our product and would actually use it in the classroom, whether it be for a lab or for a demonstration in class. And then this is our use case, and it kind of gives like the basic flow of our project. So the ball would enter the course at 3.4 miles an hour, and it would go through each of the stations. And if the ball ever escaped from one of the stations, you could either put the ball back on the ramp where it entered, or you could put it back into the station in which it left. And it'll exit the ramp at 3.4 miles an hour.
So based on the result of the customer interview, the customer needs can be divided into 2 categories: primary needs and secondary needs. Well, firstly, the BRG can be safely used in a classroom and in a laboratory. And then the BRG can demonstrate physics concepts on circular motion and motion on an inclined plane. And besides, the BRG has a nice design and it is cost effective. The customer we target are teachers and instructors from secondary schools, so they don't have such a big salary. So the team decided to make the BRG product affordable enough for most customers to buy in the market. And finally, the BRG station are compact and is able to be stored in most science labs. Because storage space is an issue in most science labs. So ideally, the BRG product should be able to be disassembled into small pieces for storage.
The team created a quality function deployment chart which puts the customer needs and the specifications in correlation. And the 2 important customer needs that we found were compact size and the course working reliably. A few other ones that we felt were important too were the price and easily seen in the classroom setting, so multiple people could be using it at one time. And our specifications that we found were the setup time, size of the shipping container, durability, cost, ball entering and exiting reliably, viewability from a distance, and the total mass. And in the bottom right corner is the correlation between our customer needs and the specifications 1 would be the lowest correlation and 5 would be the highest. So for the important customer needs, we found that compact space had a 5 for the size of the shipping container, and the course working reliably had a 5 for ball entering and exiting as intended. The team came up with some benchmarking data, and we found 2 kits that we thought were similar to our design. The first one is a hydraulic machines kit, and the second one is a simple pendulum. The first one sells for $31, which is less than ours, and the second one sells for $125, which is much more than ours. We plan on selling ours for about $50. The amount of students is 3 to 4 for the first one and 36 for the second one. We plan on targeting 3 to 4 students as well. They target a 9 plus age group, and the other one targets grades 9 through 14. We are going to target strictly high school physics students. They have 4 experiments in the first one and 1 experiment in the second one, and we plan on having 3 experiments all tied in to the 1 BRG.
Speaking of economy, the team chose to use scenario 1 in selling the BRG product. The team assumes that the fixed cost of the project is $11,250 per year, and the variable cost is $20 per unit, and the selling price is $50 per unit. And then the team estimates the total revenue by multiplying the selling price by the number of units sold. As we can see, the total revenue is the blue line. And then the team calculates the total cost by adding the fixed cost to the product of the variable cost and the number of units sold. As we can see, it's the orange line. And finally, the team calculates the profit by subtracting the total cost from the total revenue, and then we get the line below. As a result, the team needs to sell at least 375 units per year to reach the break-even point.
Here's a quick look at the future. We'll be looking more in depth into some patents that are relatable to some of our courses in our BRG, and we'll start to develop some more concepts and make prototypes up for those concepts. And then finally, we'll be able to test these prototypes to finalize and come to our final decision on what our design will look like.